Let me just put on my freaking glasses. Okay, these are all of the techniques you'll need to absolutely cook in specialist maths, right? The integration techniques, right? They're not that difficult to know. There's only a couple of them. There's only a few. There's only a couple of them you might maybe need to use in your exam. And then there's a couple of them you should probably know because it's on your freaking formula sheet. So then, let's look at the first one. Number one. Please know your methods formula sheet, or if you're not going to know your methods formula sheet, please at least know your special formula sheet, because the formulas they're right here, and they're there, and you know somewhere else. They're all over the formula sheet. Please know them. Please. That's like basic number one. Because it's a prerequisite, you do need to know the method stuff in order to do the special stuff. Like, obviously you need to know the basic stuff so you can go up and then freaking nerd emoji the exam. However, right, some formulas that aren't on the methods formula sheet are going to be the arcsine, arccos, and arctan. Yeah? Now, arcsine and arccos are pretty straightforward to look at. They literally look like this. Like, if you're able to get the integral into the form of this, like either of these two, you can actually use in like inverse sine or inverse cos. It doesn't really matter. If you want to put a negative out the front and be special, you can. The examiner doesn't really care. It's more like they give you a form to look at and then they get you to get the answer, but it's fine. Arctan's probably the one you want to look at more because it's got that little, the tiny little difference. It's minuscule, yeah? And it's just that A, you know, the A at the top, the A in the numerator. You need to know that, right? Because I've lost so many marks by just forgetting this A, and then you're like, actually, this is what the formula sheet says. So, whenever you're doing integration, probably want to look at the formula sheet. It looks like this. It's this big. It's like that big. It's that size. Please look at it. It's really, really incredibly important. Now, let's get on to the more specialist maths things. The things we think of when we look at specialist maths. And the first thing I think of is U substitution. U substitution. It's probably like your go-to technique. If you're going to pick any technique to go to, it's probably going to be U sub. And the thing you want to look for is a reverse chain rule. People are like, look at this cool technique. It's better than U substitution. It's the reverse chain rule. When they use U sub to actually get the answer. Basically, any integral in the form of this, maybe even this. If you really want to be special, could look like this. But if it really, really wants to be like cringe, it could look like this. But that's besides the point. The basic idea behind it is going to be, you need to see that, well, a function, right, f of g of x, and you know, you have to see that it's multiplied by g of x's derivative, g dash of x. This is like the most basic form of chain rule you can use, or reverse chain rule, or U substitution of, you know, we're a normal person. And it's just important to be able to, like, this is not something you can pick up really easy. You need to do a lot of practice questions in order to recognize it, because when you start to realize that U substitution is literally, can you look at the fucking the integral and then get the answer, right? That's the answer there. So you just want to do a bunch of practice questions. Just look at the textbook, look at past exams, and you'll get there in no time. Now the next one is going to be linear substitution. It's basically just U sub, but with extra steps. It's for basic, like whenever you see this thing or this thing, you know, these two things, they both suck to do. I wouldn't do them by hand. I'm sure as hell not doing them by hand. So that's why we use U substitution, or linear substitution, as the textbook calls it, in order to do these questions where you let U equal this and U equal that, and you rearrange and you do use your normal U substitution. Now, once you have those two down pat, it's pretty chill. It's pretty chill to understand linear substitution, because it's literally, can you just like, you know, make it easier to solve. You can solve it like this if you want. Expand the brackets all you fucking want. But I'm not gonna do it. Either way, either or. The biggest thing we need to remember for U substitution, and we have to salute some poor men who have lost their lives to this issue. And that issue is the boundaries. You need to remember to change your boundaries. If you're going to do a U sub, you have to change the boundaries. Upper terminal, lower terminal, they both change when you do a U substitution. There's no, but what if? No, it always changes. Always, 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 okay? Just remember that. Now, U substitution obviously can be taken to a couple other forms. It can look like this, or... My bad. Big thing we want to look at next is trigonometric substitution. Now, let's put the calculus 2 shit aside, because I'm be so for real, you're not gonna have to do that or that, like, ever, for if you're just doing, like, spec. Maybe if you want to go to university math, then you can figure that out. But trigonometric substitution will only apply when you have trig functions involved, like, no shit, it's trigonometric sub, you want to use the trig identities to simplify it. And trust me, it's also another thing you have to just know by recognition. That's just by doing a bunch of practice questions. There's no easy way to be like, this is the answer. No. Literally, just do practice questions and you will be so chilly when it comes to you or trigonometric sub. Because actually looking at it and being like, what identity can I use to turn it into the form of anything on my formula sheet? I'm gonna stop swearing because it's getting bad. This is a kid's video, guys. So then, let's then build upon this with our idea. What's the next? Let me just look at my notes real quick. What's the next?
One eternity later.
So partial fraction decomposition. Basically, let's use the whiteboard here. I'm just gonna write it. Now, partial fraction decomposition. Have I done 3 takes for this? Absolutely. But that's because it's a good technique to know. It's really easy to tell when you need to do a partial fraction because it's literally just going to be polynomial divided by polynomial. The big thing you need to remember is in the VCE, we normally deal with it being smaller at the top and larger at the bottom. Like, what I mean by that is a higher degree and then a slower degree, which is, like, you can think about it like that, or you can, like, you know, make it real complicated. But we're not going to worry about that. Basically, you just need to know these forms here for partial fractions and how, like, you can reduce a quadratic into these, or not reduce a quadratic, reduce a fraction into these partial fractions, as they call it, like these 3 forms. And then if you really want to be special, we can then just, like, turn it into this, like, you know, like this, if you're given, like, a 5th order polynomial where you're given, like, a linear, a quadratic reducible factor and a quadratic irreducible factor, like that. It's cool, trust me. You can break it down, you can do what you want, and then it just turns into a log, or if you're unlucky, an arctan. But just remember, if you're using this technique, the big thing you want to remember is that most of the time it's just going to turn into either a log or I dropped the pen again. An arctan. An arctan is the big one that a lot of people will miss with irreducible quadratics. Basically, you want to get used to completing the square of these, like, irreducible quadratics when doing partial fraction decomposition, because if you don't do that, you're going to be kind of cooked, because you'll be sitting there being like, this isn't on my formula sheet. Well, yes, it is. You just haven't, you know, complete the square yet in order to get the answer, in order to make it look like something. It's on your formula sheet. So we'll jump to the next one. My personal favorite, my go-to technique when I'm all out of options: integration by parts or the table method. Now, I would recommend, instead of using the integration by parts they have on the formula sheet, use this table method as shown here. Maybe if I put it here, editor Thiessen, put it on. Basically, what I'm trying to get from here is this table just makes it really easy to do these questions compared to using this, which is just like, if it's gonna be like a cringe question, like, I don't know, that, you don't want to do that with, like, a bunch of, u equals this, v equals this. No. We're just gonna turn it into the table and then just, you know, break it down until it finally gets to something easy. Now, usually when we see integration by parts, it's a product of 2 functions. That's the big thing you want to remember. And it's also probably the go-to one when U sub fails for any sort of question. So, like, for example, this thing, like, I don't know why I pointed in 2 directions. Is there 2 equations here? I have no idea, but there could be. There could be though. What if is the real question. Now, those are the big techniques you have to know for specialist maths. There's like a couple others like recognition, but again, recognition is something that's covered in methods. So basically, if you know your methods integration skills and your special integration like techniques, those are all you really need to know for the basic stuff. Obviously, there's the application, the formulas that come with that, the exam itself, but just focus on learning those techniques and getting as good at them as possible, because trust me, calculus is actually a really big part of the exam if you want to do well. If you want to f around and find out, that's on you, but don't blame me. Anyway, that's my integration specialist maths guide. Have a good one.